Alright, finishing up number 19, we're going to solve for the acceleration if m2 is greater than m1. So I'm going to call clockwise the positive direction. So our force diagrams, you've got m2g going down, tension up, and then you've got m1g going down and tension going up. Those two tensions are the same. So our net force equation would be m2g minus m1g equals m1 plus m2a. And so just divide by m1 plus m2. And you get F. Last problem. Numero 20. The block slides down from rest down a 20-degree ramp. The graph shows how the displacement of the block from the top of the ramp varies with the square of the time t after release. And we want to know the acceleration and mu. So we've got delta x versus t squared. So this is giving us two parts of one of the kinematic equations. We've got delta x equals vit plus 1/2 at squared. If it starts from rest, we can get rid of vit. So essentially we've got delta x equals 1/2 a times t squared. Our graph has delta x as the y, and it has t squared on the x-axis, which means the slope of our graph, y equals mx plus b, is 1/2 a. Okay, so the slope of this graph is half of the acceleration. That's the key here. This is like a bonus type of problem. Don't worry about if you didn't get this one right. Slope is half the acceleration. So if you find the slope of this graph, it's 0.417. And that would be meters per second squared. And if that's half the acceleration, that means the acceleration is double that, 0.83 meters per second squared. So that's what the use of the graph was for, was to get the acceleration. Then it wants mu, so it says that this block's sliding from rest down the ramp. So, force diagram, you've got mg, normal, force of friction, and then we can break our force of gravity into mg sine and mg cosine. So the net force downhill equals ma. Net force downhill is mg sine theta minus force of friction uphill, which is mu mg cosine theta, all equals ma. We don't have the mass of the block because we don't need it. We have g, we have theta, we have a. One thing we don't have is mu, which you can solve for, and it's 0.27. Also, I believe this is a typo, that it's supposed to be mu k. I don't think we caught that before we printed it. But it's sliding, so mu k. Good luck on the test. See everybody on Friday.